Alright, well this is Algebra AB Unit 8 review video. We are looking at polynomials this unit. We are talking about how to add, subtract, multiply these polynomials. I want you to keep in mind everything we do when we are adding or subtracting has to be with the like terms. You cannot add or subtract if the terms are not alike. So when we have this subtraction here, the first thing I want to do is distribute that -1 to each piece here. And I'm going to rewrite my equation. 4a cubed minus 2a squared plus 1, just like normal. And then I'm going to distribute that -1 to each piece. So you get a -a cubed, a positive 2a, and a -3. Then I'm going to combine the like terms. I see here I have a 4a cubed and a -a cubed. So when I combine those like terms, I get 4 minus 1, so that's 3a cubed. My second term is a -2a squared. I don't see any other a squares here, so I just write him right next to his cubed buddy, and I'm done with that guy. The next term I see is a 2a. He doesn't have any other like terms in this sentence, so I'm just going to add him on. And then I'm going to combine my whole numbers. I've got a +1 and a -3, so that combines to be a -2. In my answer, I have it where the highest term degree comes first, and then it decreases from there, ending with my whole numbers. I have combined all like terms, so I know I'm finished. For the next one, we're just adding those two terms, so I don't have to distribute anything. I just look at combining like terms. So my first term is that cubed, that's 3y cubed. I don't have any other y cubes in this sentence, so I know that he's just by himself. So I write him up here, 3y cubed. Then I look at my next term, and I see I've got a 4y squared. There's no other y squares in here, so he is also by himself. That's supposed to be a 4. 4y squared. So I'm done with 4y squared. The next term would be just a plain y. I've got one right here. It's a 4y. There's no other plain y's in my sentence to combine it with, so I just add him on as well. Last, I've got my whole numbers. I've got two whole numbers, a 14 and a +2. So I combine those. 14 plus 2 is 16. Moving on to the next one is subtraction. So I have to distribute that -1 and rewrite my sentence. I've got 3a minus 5a cubed plus 2a squared, and then distribute. -1 times 8a cubed is a -8a cubed. Then you'll distribute to the 6a, and you get -6a. Then a -1 times a -1 comes out to be a +1. Next, I'm going to combine my like terms. I want to start with that highest degree. So here I've got a -5a cubed and a -8a cubed. When I combine those, they're both negative, so I'm going to add them and keep the negative sign. So you get -13a cubed. And I'm done with those guys. The next term I would look at are my a squared. I've got a 2a squared here. And none of the other terms are a squares, so I just tag him onto the end right here. And I'm done with him. The next term I would look at are my regular a's. I've got a -6a here and a +3a. So when I combine those two, Negative 6 plus 3 is going to leave me with a negative 3a, and I'm done with those guys. Then I've got one whole number, that's plus 1, so I don't have to combine it with anything, so I just add it on to the end. Last one here, we've got addition, so we don't have to distribute anything. We just look for our like terms in order to rewrite it. I want to start with the largest degree, so that would be my 4h cubed. There are no other h cubed, so I just start with him by himself. Then I look at my h squared. I only have one h squared right here, and it's a negative 2h squared, so I write him next. And I'm done with him. Then I want to look at just the regular h's. So I've got a negative 3h and a positive 10h. So I combine those to get a positive 7h. And I'm done with those guys. Then I add my whole numbers last. The only whole number I have here is a positive 12, so I add 12 on to the end. Next, we're going to multiply. That's what it means when it says find the product. We're going to multiply each one of these. Remember, when you are multiplying variables with exponents, you add them. When you're dividing, you subtract. And when you're raising them to another power, you multiply the exponent. That's something we learned last unit. So I'm going to multiply negative 4n to each piece here. Multiply the whole numbers just like normal. What is a negative 4 times a negative 9? It's a positive 36. Then I multiply the n's. N to the first power times n to the second power. I'm going to add those powers and I get n to the third power. Then I multiply that negative 4 times a positive 5n. Multiply your whole numbers just like normal. Negative 4 times positive 5 is a negative 20. And then add the exponents for your n's. You get n squared. Then a negative 4n times 8. You multiply your whole numbers like normal. Negative 4 times positive 8 is a negative 32. And then n doesn't multiply with any other n, so he just stays right next to that 32. This is my final answer. Six is a little more complicated because you have to distribute to each piece from d squared to d, and then d squared to the 2. So d squared times d, I'm going to add those exponents so you get d cubed. D squared times 2 is just a positive 2d squared. Then I go to the 6d. 6d times d is 6d squared, because you're adding those exponents when you multiply them. Then 6d times 2, I'm multiplying those whole numbers just like normal to get 12, and then d on the end. My last step here is to distribute that negative 5 to the d. You get negative 5d. Then negative 5 times 2, which is a negative 10. I'm not finished here because I have like terms that I can combine. I'm going to combine my d squared and my regular d's. D cubed has nobody to combine with, so he's just d cubed. 2d squared plus 6d squared is 8d squared. And then you've got 12d's minus 5d's leaves you with 7d's. And then you've got a negative 10 on the end that doesn't combine with anybody. This is my final answer because I've combined all my like terms. Numbers 7 through 10 want us to use the FOIL method. Remember, FOIL means the first times the first, the outside times the outside, the inside times the inside, and then the last times the last. FOIL. And you'll use FOIL for a long time after this, so Definitely practice and get used to using FOIL. First times the first is my p times p, which is p squared. Outside times the outside is the p times the negative 7, so get negative 7p. Inside times the inside is that positive 7 times p, which is plus 7p. And then last times the last is 7 times negative 7, which is negative 49. I combine like terms to get my final answer. I notice there are two kinds of just regular p's. I've got a negative 7 plus 7 cancels to give me 0 p's. That just leaves me with p squared minus 49. Number 8, same thing, FOIL, the first times the first. 4s times 4s, I multiply the whole numbers like normal to get 16, and then s times s is s squared. Outside times the outside is 4s times 1, so I get plus 4s. Inside times the inside is negative 1 times 4s, which would give me a negative 4s. Last times the last, negative 1 times positive 1 is a negative 1. I combine like terms, so I've got regular s's here. Plus 4 minus 4 cancels to 0. So you get 16s squared minus 1. Number 9, first times the first, 3p times 4p. Multiply your whole numbers like normal. And then p times p is p squared. Outside times the outside is plus 15p because 3 times 5 is 15, and then p is just on the end. Inside times the inside is a negative 8p. Last times the last is that negative 2 times positive 5, which leaves you negative 10. Combine like terms, you got 15p minus 8p, which leaves you with 7p. So your final answer is 12p squared minus 7p minus 10. Number 10, we need to rewrite m minus 5 times m minus 5. We know that m minus 5 squared is just m minus 5 times itself, so we rewrite that so it's easier to use FOIL. First times the first is m. Outside times the outside is negative 5m. Inside times the inside is a negative 5m. Last times the last is that positive 25. Combine like terms, negative 5m minus 5m comes out to negative 10m. So you rewrite your whole answer, m squared minus 10m plus 25. The next section, we are solving the equation. Whenever you're solving the equation, you want to set each piece equal to 0. And if it's already set equal to 0, then you might need to factor out the greatest common factor in order to solve. Here, on number 11, we've got all of our factors already factored out, and everything's set equal to 0. So what I can do is just take each one of these pieces and set them equal to 0. Q minus 7 equal to 0, and I'll get one answer. 2q minus 4 equal to 0, and I'll get another answer. And then you could always set 1 equal to 0, but that will never happen, so I don't have to worry about that one. So we solve each one of these equations in order to get our options for our answers. In order to solve for q, I would add 7 to both sides and get q equal to 7 for one of my answers. To solve for q in this equation, you would add 4 to both sides and get 2q equals 4, and then you would divide by 2. So q is going to equal 2. You've got two answers for really all of these equations. So you've got one answer is q equals 7, and the other answer is q equals 2. So both of those answers are correct. And then number 12, you've got factored out already. You've got it set equal to 0 already. So you take each one of those pieces of parentheses and set each one equal to 0. And then solve for z. To solve this one for z, the first thing I would do is add 3 to both sides. 4z equals 3. And then I would divide by 4. Z is going to equal 3/4. My next equation, to solve for z, I would add 7 to both sides to get z equals 7. So those are my two options for z. Z equals 3/4 and z equals 7. 13 is not factored yet, so the first thing I would want to do is factor out what it has in common. 4m squared and a negative 32m has two things in common. The first thing it has in common is a 4, and the next thing it has in common is an m. So I'm going to factor out a 4m and then figure out what's left. If I pull out a 4 and an m from the first, then it's going to leave m by itself. And I can double check that to make sure 4m times m gives me 4m squared. Then I want to pull out or divide a negative 32m and 4m. So from 32 divided by 4 leaves me with 8. M divided by n leaves me with 1. So you get 4m parentheses m minus 8 equals 0. You want to set each one of these pieces equal to 0. M minus 8 equals 0, and then solve for your two options for m. For the first one, in order to solve for m, I would divide by 4. And then you see 0 divided by 4 is just 0. Move my paper up for you. 0 divided by 4 is just 0, so one option for m is going to equal 0. The other option for m, to solve this equation, I would add 8 to both sides and get m equals 8 as another option. Problem number 14, a little more complicated. It's not even set equal to 0. So the first thing I would want to do is add 6u to both sides in order to set it equal to 0. That's my first step. My next step is to factor out what they have in common. I see that 3u squared and 6u have a 3 in common because I can divide 6 by 3. They also have a u in common. This one's got u squared and this one's got u. So I'm going to factor out 3u and then see what's left. When I factor out 3u from 3u squared, the only thing that's left is a u. When I factor out 3u from 6u, the only thing that's left is 2. So those are my two factors. I've got 3u that I need to set equal to 0, and then u plus 2 that I set equal to 0. In order to solve for u for the first one, I would divide by 3 on both sides, and you get u equals 0. The next one, to solve for u, I would subtract 2 on both sides, and I would get u equals a negative 2. So my two answers for 14 are u equals 0 and u equals a negative 2. Okay? Moving on. Number 15. Actually, you know what, guys? We're going to stop there for now. We're going to call that part 1 of Unit 8 review. I'm going to take a break, and I'm going to make the second part of the video at another time. So I hope that helps. And for the second part of the video, look for Unit 8 review part 2. Thanks, guys.